Okay, so here's an example. Tell where each graph is odd or those are bad directions. Whether, I was going for whether. I'm so dumb, it's embarrassing. Anyway, tell whether each graph is even, odd, or neither. Well, look for any kind of line of symmetry. We have a line of symmetry that's across the y-axis. That means if you put an x in and the opposite of x, you get the same y values. This one is definitely even. This second one, it definitely doesn't have the y-axis as a line of symmetry. And if you go from this point, for example, through the origin, you don't have another point over here. So it is not symmetric with respect to the y-axis. It's not symmetric with respect to the origin. This one is neither. And so the third one, I did my best to graph this. I think I did better than yesterday's notes. Any point, it's definitely not symmetric with respect to the y-axis. But any point that you pick, if you go through the origin, you will have a buddy point. Pick this point, go through the origin, you get that point. This one is symmetric with respect to the origin, so that function we would guess is odd. Okay, here we go. How do you tell if an equation is going to be even or odd or neither? You don't have to graph it. You go back to the directions, okay? You don't have to write this in your notes if you don't want to. But for an even function, f of negative x has to be the same as f of positive x. You get the same y values. If it's going to be odd, then f of negative x is equal to the opposite of f of x for it to be odd. You put in negative x, you get the same thing but with a negative. So here's the trick. Put a negative x in, simplify, and compare it to the original. Put a negative x in, like these negative x's, put a negative x in wherever there's an x, simplify, and compare it to the original. Okay, here we go. F of negative x here would be the negative of x squared minus 5. You see it? Now you know that if you square something, it turns negatives into positives. So f of negative x, once I simplify it, is actually just equal to x squared minus 5. There's f of x, the original. There's f of negative x, and would you agree they are the exact same? If f of negative x and f of x are both the exact same, this graph is even. I don't even have to graph it, I know it's even. Let's go to the next one, g of x. If I put a negative x in and simplify, let's see what happens. So we'll put a negative x to the third minus 1. Now you know things to the third power, that's a negative times a negative times a negative. It actually ends up being negative. So I go g of negative x equals a negative x to the third minus 1. And that's my simplified version. Now I'm going to look at my original, and I'm going to compare f of negative x with what I got. They're not the same because that's positive and that's negative. These are opposites though, but here's the problem. These are not opposites. The whole expression would have to be opposite. I would have to see negative x to the third plus 1, so therefore this one is neither, or neither, depending on how you wackos want to say that out loud. All right, here's the next one. H of negative x, I'm sorry, did I say wacko? You guys are nice people. I don't know where that came from. Here we go. F of negative x to the third minus negative x. Okay, you take negative x to the third power, negative, positive, negative. Negative, negative, negative. These two become positive, it's negative. You guys know how that goes. I'm overstating it. So here we go. That's negative 5x to the third. And this negative minus a negative x, that becomes plus x. So there's my simplified version of h of x. Here's my original h of x. Let's go term by term. That one's positive, that one's negative, they're opposites. That one's a minus, that one's a plus, they're opposites. This expression is the opposite of that expression. If I put a negative x in and I get the opposite of the original, this is an odd function. Next, we're going to do increasing and decreasing.